Welcome to this course titled Survey of Programming Languages. Programming languages form the foundation of computer science and software engineering. They are the tools through which humans communicate instructions to machines, enabling the creation of applications, operating systems, databases, games, and much more. This course introduces you to the history, concepts, classifications, and practical applications of programming languages. We will discuss how they evolved, what distinguishes one language from another, and how modern programming languages address the challenges of efficiency, usability, and maintainability. The course is divided into two modules. Module 1, Foundations, History, and Classifications of Programming Languages. Module 2, Survey of Major Languages and Contemporary Trends. By the end of this course, you should understand the essential features of different programming languages, their strengths and weaknesses, and the context in which they are best applied. Let us begin with Module 1. Module 1, Foundations, History, and Classifications of Programming Languages. 1.1 What is a programming language? A programming language is a formal system of notation that allows humans to write instructions for a computer. These instructions are then executed by the machine to perform specific tasks. Programming languages provide two critical functions. Communication with the computer, enabling programmers to instruct hardware and software. Problem solving, offering tools and abstractions to break down complex problems into manageable pieces. 1.2 Brief history of programming languages. The evolution of programming languages reflects the history of computing itself. Early machine languages, the first computers were programmed directly in binary, using sequences of zeros and ones. This was tedious and error-prone. Assembly language, to simplify, assembly languages were developed. These used mnemonic codes, like MOV for move or ADD for addition, but still mapped closely to machine instructions. High-level languages. By the 1950s and 1960s, high-level languages emerged, designed to be closer to human thought. Examples include Fortran for scientific computing and COBOL for business applications. Structured programming. In the 1970s, languages like Pascal and C promoted structured programming, encouraging clarity, modularity, and reusability. Object-oriented languages. In the 1980s and 1990s, languages like C++ and Java emphasized objects, encapsulation, inheritance, and polymorphism. Modern languages. Today, languages such as Python, JavaScript, Swift, and Go focus on developer productivity, portability, and handling modern computing challenges such as concurrency, big data, and artificial intelligence. 1.3 Components of a programming language. Every programming language has key components. Syntax, the rules governing the structure of programs, much like grammar in natural language. Semantics, the meaning of syntactic elements. For example, what an assignment statement actually does in memory. Pragmatics, how the language is actually used in practice, including style conventions and design patterns. 1.4 Paradigms of programming languages. Programming languages are often classified by paradigms, general styles of programming they support. Imperative programming. Based on sequences of commands that change a program state. Examples: C, Pascal. Object-oriented programming, OOP. Organizes code around objects, which combine data and behavior. Examples: Java, C++, C#, Python. Functional programming. Treats computation as the evaluation of mathematical functions, avoiding changing states and mutable data. Examples: Haskell, Lisp, Scholar. Logic programming. Based on formal logic, programs consist of facts and rules. Example: Prolog. Scripting languages. Lightweight languages often used for automating tasks, web development, or glue code. Examples: Python, JavaScript, PHP. Concurrent and parallel programming. Languages or extensions designed to support multithreading and distributed computing. Examples: Erlang, Go, Rust. 1.5 Compilation and interpretation. Programming languages differ in how they are executed. Compiled languages, translated directly into machine code before execution. Example: C and C++. They tend to be fast and efficient. Interpreted languages, executed line by an interpreter. Example: Python, JavaScript. These are flexible and easy to debug. Hybrid approaches: Java uses compilation into bytecode, which is then run on a virtual machine, blending portability and performance. 1.6 Criteria for comparing programming languages. When evaluating languages, computer scientists consider readability: is the code easy to understand? Readability: is it easy to express solutions? Reliability: does the language help prevent errors? Efficiency: does it run fast and use memory effectively? Portability: can it run across multiple platforms? Community and support: is it widely used with strong resources? These criteria help developers select the right tool for the job.